Welcome to YuvaTeck. So in this video we will discuss the question numbers from 914 to 916 of SSC-JE examination conducted in the year 2018. So let us see the first question. The question is, which one of the following is the statement of Ohm's law? The options are: option 1, voltage is always equal to current; option 2, voltage is inversely proportional to the current; option 3, current is directly proportional to the voltage; option 4, current does not depend on the voltage. So as we know the Ohm's law statement, so the correct answer is option 3, current is directly proportional to the voltage. So the relationship between the voltage, current and the resistance in a DC circuit was first discovered by German scientist George Simon Ohm. The relationship is called as Ohm's law. So it is stated as the ratio of potential difference between the two ends of a conductor to the current flowing between them is a constant. That is, V by I is equal to constant at constant temperature, right? Or we can say the physical conditions do not change. So based on this scientist name only, now also we are naming the resistance unit as ohms. So in simple we can say that the voltage is directly proportional to the current at constant temperature. So the other options that will not meet the statement, so option 3 is the correct one. Let us see the next question. Question number 915. What will be the value of current I5 in amps for the given network? So they have given one network. In that network we have to find out the I5 current. So to solve this problem, so what we have to do is we have to apply the Kirchhoff's current law. So they have given 4 options. So we will see what is the correct option. So what Kirchhoff's current law states is the algebraic sum of the currents meeting at the junction in an electric circuit is 0. So or in other words we can say that the sum of, if you take one node, in that node the current entering into the node will be equal to the current leaving from the node. So in this case let us take the first node or junction. We can take, as we discussed in the previous video, the difference between the node and junction. So let us take the first junction, right? Here if you see, the I1, I2 and I3 or the current enters into this junction. Okay, so 2 plus 4 plus 5, 11 amps. 11 amps is the total current. That is nothing but the I4 current, isn't it? So and if you see, what you have to find out is we have to find out the I5. So but anyway here there are 2 more currents are leaving from the second junction. So one is I6, which is equal to 2 amps, and other than that if you see the 4 amps and 3 amps, which is on the node 3, you can see those 2 currents. So here itself 7 plus here I6 2 amps. So totally 7 plus 2, 9 amps it is already there. So the total current is 11 amps, that is I4 is 11 amps. 11 minus 9, which is equal to 2 amps. So the I5 is equal to 2 amps. So if you see to find out this I5, you have to know that I4 value, which is equal to 11 amps. So then we have to find out that this will be the total current. Let us assume 11 amps. So rest of the currents we have to add, right? 2 plus 3 plus 4. So if you add, no, it will be equal to 9. 11 minus 9, which is equal to 2. That is nothing but the current of this I5. So whatever the problem, if it is given in this network form, what you have to do is you have to take the junction or a node. There you have to equate it, that current entering into the node which is equal to current leaving from the node. Like that, if you calculate, you can easily obtain the answer. Very simple question, both are. Let us take the next question. It is also a simple one only, but we should know one small logic. The question is, determine the Thevenin's equivalent resistance in ohms across the terminals X and Y for the given electrical circuit. So they have given one electrical circuit, in that they have marked X and Y. So they have given 4 options. Within these 4 options, we will see which is the correct answer. So if you want to determine the Thevenin's resistance, what you have to do is, you have to short circuit the voltage sources and open circuit the current sources. So if you apply that rule, what will happen is, this 8 ohms and 6 ohms, because no, we are short circuiting this 20 volts and 10 volts, right? So if you short circuit, you can find that the 8 and 6 ohms resistance will be in parallel. So whenever you are finding the total resistance with respect to X and Y terminals, right? So if you find out that equivalent resistance based on this parallel combination, 8 into 6 divided by 8 plus 6, which is equal to 3.43 ohms. So in this options, option 3 is correct, which is equal to 3.43 ohms. So like that, you have to find out the Thevenin's resistance. Thank you.